Okay, let's do some more math. I know, what you all signed up for, literally. More math. So I don't know if this is in R7 or R8. I'm just gonna say both. They change the order of shit around. We're dealing with rational exponents and radicals in this section. Now, when we had rational expressions, we had expressions that made fractions. When we have rational exponents, we have exponents that are fractions. So that's where we're heading here. Fractional exponents. And how they connect to radicals. So let's just go over some quick rules. The rules of the game. If I had a to the n power and then multiply it by a to the negative n power, we looked at what happened with this before. When we have multiplied together, we add the exponents up. And n plus negative n is 0. So I have a to the 0 power. But if I write this another way, a to the negative n means this part right here becomes 1 over a to the n with the rules of negative exponents. And so if I multiply these two together, I get a to the n over a to the n. And anything divided by itself is just 1. Except 0. 0 is a fucking rebel. So all of these operations were legal, which means these two have to be equal. A to the 0 equals 1. So the big takeaway from this, and I think I talked about it before, anything to a negative exponent just becomes the reciprocal of it with a positive exponent. And this also applies if the negative exponent is on the bottom. So I can move some number with an exponent to the opposite side of the fraction if I just make the exponent the opposite sign. Where you might have seen this before is in any of your science classes. They have scientific notation, like they have 10 to the negative 3. This is really just 1 over 10 cubed, which is 1 over 1,000. You do want to be cautious. If I have something like that, the negative 2 says I can move it to the bottom. But the negative isn't part of it, which doesn't really matter in this case, but it is worth noting. If I move it to the bottom, it becomes positive. Exponent. And only the exponent becomes positive. Don't make the sign positive. So this becomes -1 over 5 squared is 25. And this is different than -5 over -2 to the -2 power. This becomes 1 over -5 squared. And -5 squared is also 25, but this one doesn't have a negative in it. This works with fractions. If we have 4 over 9 to the -2. I could do this. To the +2. That's not ideal. When you have fractions, just move them to the other side of the fraction. Instead, I'm going to move the 9 to the top, put the 4 on the bottom, and just make it squared. This is kind of like distributing that -2 to each of them, and then moving it to the other side of the fraction. In both cases, you end up getting 81 over 16. So like a general form of this is like a over b to the n power is the same, let's say -n power, is the same as b over a to the n power. Because it doesn't just have to be numbers, it can be rational expressions and stuff like that. Oh, that'd be dirty. Combine this with the rational expression. Level up, Jones. This sounds like a new problem. How can I make this class harder? And I swear I've done that before. It's got to be in previous notes. I must have just covered it early. I like to do that sometimes. If I have a over m, or a to the m power over a to the n power, this is a to the m minus n. It's what we used a little bit ago. Kind of thing. So I could have like 2y to the 4th power over 5y to the -3. There's a couple ways of doing this, and either approach works. One approach is doing this rule right here. I have 2, and then I've got y, I've got 2 over 5, and then I've got y to the 4 power, that's the top, minus the bottom exponent, which is -3, which is going to give me 2/5. 4 minus -3 is +3, so 7. So you can do the subtracting exponents when you're on the opposite sides of the fractions. The other way is doing the rule about moving the exponents that are negative. Alternatively, I could treat this as 2y to the fourth over 5. When the y to the negative 3 moves to the opposite side of the fraction as y cubed. And when I do that, now they're multiplied together, which means adding those exponents. And I get 2/5 y to the 7th power. So both methods work when you're dealing with negative exponents in the denominator. All right. You guys try one? Why don't you guys simplify that? Hopefully, depending on how you did it, you should have definitely factored and gotten the 5s to cancel. And I'll do the subtraction one. You're going to end up with 7/5 r to the 10th power. Let's take a look at cleaning this one up. So when we have exponents on the outside of a parentheses, we got to multiply it by all the exponents on the inside. This is gonna, the 5x cubed stays the same, but I'm gonna have 2 to the negative 1 times negative 3. And then I'll have x to the 4th times negative 3. Which gives me 5x cubed times 2 cubed x to the negative 12. And now I can multiply these together because 2 cubed is 8. So 5 times 8 is 40. And with the exponents, the x's are multiplied together now. So I can add the two exponents. 3 plus -12 is x to the -9. And so when I move the x to the -9 to the other side of the fraction, I get 40 over x to the 9th power. I think that's the easiest way to do it. Get everything down to where the exponents are just one thing and then look at moving things. You have an alternate form that you could do. Like I could have 5x cubed. And since this is a negative exponent, I could move it all the way down and make the exponent positive. And I could work that route as well. I could work that route along, but eventually you're gonna get to 40 over x to the 9th power. So there is more than one way to get things done. So let me give you guys another hard one. Let's have you guys do, we're gonna have 4y cubed, that will be to the -2 power. And then I'll have 4y to the -1, and that'll be to the -3 power like this. And then I will have 4 to the -1 b cubed, and we'll put a -4 there. Because that's how I roll. Just doing that distribution, make sure everybody's on the same page. That should be a Y. I don't know why that says B. My bad. You're like, what the hell is he doing? What is the B from? Fuck. Oh, we got a B. All right, if you clean that up a little bit, what we got? We've got 4 to the -2 times Y to the -6 times 4 to the -3 times Y to the +3. And on the bottom, I've got 4 to the 4 and Y to the -12. So if I do the stuff with the 4s, all the things on top can be added together. The exponents, I got -2 plus -3. And then I can subtract any exponent on bottoms for the board. So I can do -4 for the exponent on the bottom. I do the same thing with the Y's. I've got -6 plus 3 for the 2 on top. And then I subtract the exponent on the bottom, so minus -12. I add those together, I get 4 to the -9 and Y to the 9. Oh, wait, no. 12 plus 3 is 15 minus, yeah. And the only thing different I could do is maybe move the 4 to the bottom. I guess I could write out what 4 to the 9th power is, but that's a really, really big number. And I kind of don't want to do it. So we're going to leave it as that. And I'm just going to start it. We're going to look at it just so it's simmering in your brain for Thursday. We have rational exponents, fractional exponents. Where do these come in? Another way of writing this is the nth root of a to the m power. I can also put the m on the outside. I could have the nth root of a to the mth power like that. And that's kind of like, because this, I could write this as a to the m times 1 to the nth power. So one you guys know, the square root of 3 when you don't see the index out here, the missing index is really a 2. So doing square roots just means writing the exponent. I have an exponent of 1 on the inside. This becomes 3 to the 1/2 power. So square roots are 1/2 exponents. Now, what n is, put some restrictions on it. If n is odd, a can be positive or negative. Like I can have the cubed root of -8. That's valid. Here n is 3. If n is even, a can't be negative. Not yet, not for real numbers. Not if we want a real answer. A real value answer. When we do have that, like the square root of -4, n here is 2 is even. This leads to complex numbers that we'll cover later. Covered later. That good old I, the imaginary number, if you've had seen it before, that's where that comes in. It's important. I don't know if you've ever had a teacher tell you why. Our electric circuit, alternating current, the mathematics behind it uses complex numbers. It works based on the math theory behind it, uses complex number theory. That's crazy, right? Let's call it a wrap. We'll be doing a lot of radicals and fraction exponents on Thursday. Don't forget the Mesa Center thing is open till 6 upstairs, and let me tell you what room it is. It's in room B218. And that'll be all. You too.